So hello everyone, I'm Maurice Moneni. In today's class, we are going to discuss how we can solve the crammers, the simultaneous equation using a crammers. And with me, I have an example here, which we have 3x plus 3y plus z is equals to 3, and 4x plus 5y plus 2z is equals to 12, and then 2x plus 7y plus 3z is equals to 6. And we know to use this formula, we can get the value of x by saying the value of x is equals to, and say that our x will be given by dx divided by do, and then our y will be given by dy divided by do, and then our z will be given by d z divided by do. So remember, do is the determinant of original matrix. So in this, we can start by getting the do, and for us to get the do, we need to arrange this matrix or this simultaneous equation. We form the matrix. So we can have the first column with the values of x coefficient, which is 3, 4, and 2, and then the values of y coefficient, which is 3, 5, and then we have 7, and then we have 1, 2, and then we have 3 there. And then for us to get the determinant here, we consider the first two columns here, which we have 3 and 3, and then we have 4, we have 5, and then we have 2, and we have 7. So we pre-multiply. So for us to be able to get this matrix, the determinants, we consider our first row here, which we take this diagonal, which is there, which is 3 multiplied by 5 multiplied by 3. That diagonal there, that is made by that, which gives us a 45. And then we also consider this other diagonal here, which is made by this other element. And in that diagonal there, we shall have 3 multiplied by 2 multiplied by 2, which gives us a 12. And then we also have the other one, which is 1 multiplied by 4 multiplied by 7, which gives us a 28, And then I consider the other diagonals here. So in this case here, I'll have a 45 now added to 12, then plus 28. Then now this, I'm going to minus what is made by the last diagonal here, which is a 2 multiplied by 5 times 1, which is a 10, and also which is a 7 multiplied by 2 multiplied by 3, which gives me a 42 here. And then I also have 3 multiplied by 4 multiplied by 3, which gives me a 36. So here I'll have this one multiplied by 10 plus this one is a 42, then plus the other one is a 36. So if I add this, I'm going to have 85 minus the other one. If I add, I'm going to get 88. So my do is equals to negative 3, So now let us get the dx. In our dx, we know that dx will be arrived at what I have on the x column. I change it with what is on the equal side. So I'll have instead 3, 12, then I have 6, and the other column doesn't change, so I have 3, 5, and then I have 7, and then I have 1, 2, and then I have 3, and then all these are multiplying it with the first two columns here, which is 3, then 12, then 5, and then 6, and then 7. So if I multiply this, I consider the first column here, which is made by this, which will be 3 multiplied by 5, which gives me a 45. And then also I consider this, which is made by this, which gives me a 3 times 2, which is a 6. Then 6 multiplied by 6, which gives me a 36 here. And then I consider this, which gives me a 84 because of 12 multiplied by that. Then I also could consider this 6 times 5 times that, which gives me a 30, which gives me a 30 there, a 30. And then I consider this 7 times 2 times 3, which gives me a 42, which gives me a 42. So I'm adding this 42. And then I consider the last one, which gives me a 3, 3 multiplied by 12 multiplied by 3, which gives me plus 108. So now to get the dx, my dx is equivalent to 45, then added to 36 plus 84, then all these I subtract 30 plus 42 plus 108. So now when I add these two, I get 165 here, then minus 180 there. So this one gives me a negative 15, negative 15. That is my dx. And I know that to get the value of x, I'll use the dx divided by do. So now I'll have, remember my do was negative 3, so I'll have negative 15 divided by negative 3. And this gives me my value of x is equals to 5. My value of x is equals to 5. So the next thing is to get the dy. So I know to get the dy here, it will be arrived at by changing. Remember the first rule, that is 3, 4, and the 2 doesn't change. So now what I have on the other equal side, I replace with the coefficient of y here, which is 3, 12, and then 6. And then this one, I'm adding it 1, 2, and then 3. Then I reconsider my first two columns here, which is 3, 4, 2, and then I have 3, 12, and then 6. So now these, I can be able to reconsider the first row. So here I have this, I multiply. So if I multiply 2 times 12, I get this one being a 24. Then 24 plus, I consider this 6 times 2, which is 12 times 3, which gives me 36. And then plus, if I consider this, also gives me a 12 times 3, which is a 36 also. Then I can consider this other column here, which gives me a 3 times 12, which is 108. And here I have 3 times 2 times 2, which gives me a 3 times 2 times 2, which gives me a 12, which gives me a 12. And then I also have this column here, which gives me a 24. So now I can say that my dy is equivalent to 108 plus 12 plus 24. Then all this I subtract it to the 24, plus 36 plus 36. So now if I add these, I get 144, then minus 96, which gives me 48. So in that perspective, my y value is equals to dy divided by do. So in this case, I'll have 48 divided by negative 3, which gives me my value of y as negative 16. So that is how I can get the value of or y, the value of z. So we know that our dz will be equivalent to, we change, what we are going to change is what is on the equal side, we substitute with the z coefficients. So in this case, I'll have 3, the coefficient 4, 2, and then I have 3, 5, and 7, and then I have 3, and then I have 12, and then I have 6, and then this one I'm multiplying it with 3, then 3, then 4, and then 5, and then I'm also multiplying it with 2 and 7. So I reconsider this column here. So I'll have that one being 3 times 5 times 6, which gives me a 90. Then I consider this, which gives me 3 times 12 times 2, which is equivalent to 72. And then also 3 times 4 times that, which is equivalent to 84. So then I consider this other half column here, 3 times 2, 3 times 2, 6 times 5, which is equals to 30. Then plus, I reconsider the other one, which is 7 times 12 times 3, which gives me a 252. And then I consider the last column here, which is 3 times 4 times 2, which gives me a 72. So now my dz is equivalent to 90 added to 72 plus to 84. All these I subtract 2 from 30 plus 24, 252, sorry, plus 72. And then all these now, if I subtract, I get 246 here, then minus 354. And then these, I get my dz as negative 108. So I know my z will be given by dz divided by do. So, and in that case, I'll have my z being equivalent to negative 108 divided by negative 3 by negative 3, which gives me, which is equivalent to, my z is equivalent to 36. My z equivalent to 36. So in that perspective, we can say that the value of our x, the value of x was equivalent to 5, and then the value of y was equivalent to negative 16, and the value of z is equivalent to 36. So if we take our first equation where we had 3x plus 3y then plus z is equals to 3, let us substitute. We see if we are going to get this. So we are going to have 3 multiplied by 5, then minus 3 plus 3 negative 16 here, and then plus 36. So remember this one is 15, then minus 48, and then plus 36 there. And if you add this, you're going to get this one being 3. So you can see our equation is true. And that brings us to the end of this session. I was your trainer, Maurice Monene. If you found it of any benefit to you, please consider subscribing, share, and like it so that it can reach more to have the same knowledge. Thank you.